Hello guys, good evening everyone. Welcome to the India's most comprehensive preparation platform, that is the BYJU'S exam prep, and welcome to the monsoon course. Yes, the GATE Rankers monsoon course, which has been going on across different branches, and today I am live to discuss up some of the important concepts of the Z Transform. Yes guys, quickly everybody join the session. Let all students join the session quickly so that we can begin up the discussion of Z Transform. And as the title says, today in this class we are going to discuss about the basics of the Z Transform and its associated ROC. What is the ROC? Very important. The ROC is actually a very important topic. What type of questions you expect? So first, let's go through the basic part of Z Transform ROC. Then we shall take the questions. First, before going to questions, also we'll take the different properties. So in an entire week in this monsoon course, we are learning something about the Z Transforms and the DTFT, because Z Transform has a very simple and good connection with the DTFT. So that also we'll try to explore within the same session. Yes guys, just a second. So quickly share the session to all your friends, whoever are preparing or willing to prepare for the GATE examination. Yes guys, so let's get started. People are joining and the students will keep joining. Let's keep the show going on. This is a brief intro about me. Your mentor, Educator Rakesh. I have secured All India rank 9th in the GATE examination and completed my masters from Indian Institute of Science, Bangalore. Trained more than 50,000 students in my more than 12 years of teaching experience, and this is what is my major area of expertise, where I commonly deal with control system, signal and system, EMT and digital electronics in the tech domain, and in the general domain I also deal with the aptitude and maths. Hi Soumya. Okay guys, okay, so let's get moving ahead. Let's start the show and let's get moving ahead. Also guys, an important update for you that many a times recently, at least I have faced lots of query regarding to the short notes. Okay, so I thought let me come up with a general talk on that. So detailed notes, short notes, micro notes, what do you read right now? What are more important, and what should be the difference between your detailed notes, short notes and micro notes, right? When to make these? All of this I'm going to discuss on a session that is Thursday at 11 p.m. because 9 p.m. I am busy with the signals class. So 11 p.m. Thursday we are going to talk about this particular session, right? The notes, when and how to make the notes and what type of notes are more important for your preparation, right? Good evening Sneha, Ashok, Ruby, very good evening all. And guys, tomorrow, yes, that is 12th July at 8 p.m. Tuesday at 8 p.m. the BYJU'S exam prep on the app. Yes, on the app. Once again, you have a free mega GATE workshop. Yes, and to be taken once again by your favorite Abhinav Negi sir, more than 10 years of experience and IIT Delhi alumni. Yes, do's and don'ts during the GATE preparation, what you should do and what you should definitely not do for the GATE preparation. Abhinav sir is going to speak in this workshop, that is tomorrow at 8 p.m. Tomorrow at the 8 p.m. So guys, let's get started with the show. Then let's get started with Z Transform. And guys, let me tell you, since we are dealing with the monsoon course, right, and my intent will be in this monsoon course, at least for this week, as I told you, we are discussing everything about Z Transform and DTFT. So it will include the basics of Z Transform, the properties and all variety of questions, including the, when we go to DTFT, including the frequency based questions, including the filter analysis and all those things also we are going to discuss up throughout the week, right? Good evening Ashok. So in this monsoon course, in this week of monsoon, we'll be focusing more and more on Z Transform, DTFT, their application, their property and the questions, right? So yeah, let's be more application and property and question oriented, right? So let's directly define the Z Transform and let's start evaluating the Z Transform for some of the important signal. So Z Transform for a signal is basically given by summation minus infinity to infinity x and z power minus n, right? Now what is z actually? You should all know, you should all remember that z is in general a complex variable. Z is in general a complex variable which is written in the Euler form. Z is written in the Euler form as r e raised to the power j omega. Good evening, dreamer. Z is written in the Euler form, that is r e power j omega, where r is the modulus, of course. R is the modulus of Z, and omega is known as the argument or the face of the complex number. Argument or face of the complex number. If I specially take modulus of Z equal to 1, if I take those complex numbers which are having unit magnitude, that is r equal to 1, then I am able to write Z is equal to e power j omega. And this is one important connection. This is one important connection we are going to explore, after 2 or 3 classes. Yes, when you take Z is equal to e power j omega, the x of Z, which becomes x of e raised to the power j omega, that means eventually it is a function of only omega. Eventually it is only a function of omega, right? So we also simply write it as x of omega, and in that case the formula becomes summation of xn z raised to the power minus n, and z is e power j omega whole power minus n. It becomes e raised to the power minus j omega n. It becomes e raised to the power minus j omega n. The summation of x and e raised to the power minus j omega n. The summation of x and e raised to the power minus j omega n is basically primarily known as the DTFT. So yeah, we are not discussing DTFT right now. We will discuss this in a separate session within the same week. Good evening, Satish. But yes, just I am trying to give you the hint that the DTFT is so closely related to the Z transform. It is just one of the special case of Z transform where you take the modulus of Z is equal to the 1. So let's proceed with this formula. Summation of x and z power minus n is basically known as the Z transform. This is the basic review of the formula. Xz is the Z transform, xn is the discrete time signal whose Z transform you want to calculate, and z, now, when we write down simply this Z, that is known as the Z transform operator, evaluating the Z transform of a signal, right? So that is what the DTFT and its connection with the Z transform. As I already told you, x of e power j omega or x of omega will be obtained by putting Z is equal to e power j omega. That means I can say that DTFT is the Z transform evaluated at Z equal e power j omega. Achha guys, one important question for you. Before coming to DTFT, I told you mod Z equal to 1. Can you say mod Z equal to 1? What is the mapping of mod Z equal to 1? What is the map? What is the graph of mod Z equal to 1? Mod Z equal to 1 represents what? What does it actually represents? Good evening, Gopinath. Good evening. Mod Z equal to 1 basically represents what? Can we talk about that, guys? Can we talk about what does mod Z equal to 1 represents? Any idea? What does mod Z equal to 1? We should be very basically knowing it. So forget mod Z equal to 1. If I generally want to talk about mod Z equal to A, let's say mod Z equal to A, any value. So if mod Z equal to A, we should all know how to calculate the magnitude of any complex number, right? If you take Z is equal to x plus jy, that is in the Cartesian form, the modulus of Z is given by square root of x square plus y square, and that is equal to A. So I have x square plus y square equal to A, which is a circle, whose center, now this is going to be useful in our discussions, the circle with the center at origin 0, 0, and the circle having the radius equal to the A units, having the radius which is equal to the A units. So when I want to discuss about modulus of Z equal to 1, it represents a circle with center at origin and the radius equal to 1 unit, and we commonly refer to this circle as the unit circle. This is what is basically known as the unit circle. Okay. So mod Z equal to 1 will primarily represent a unit circle having the radius equal to 1. So just keep these things noted, okay? So what I can now say is, ki Z transform evaluated over the unit circle is the DTFT. DTFT, which we are going to speak about that in a different lecture. But Z transform, DTFT is the Z transform evaluated over unit circle. Z transform evaluated over the unit circle is the DTFT. Keep this on hold. We will discuss this. We will come back to this. Now, let us take one very basic calculation of Z transform. If any time you have learned the Z, signal system earlier, you might have noticed one simple answer, one simple trend, that whenever it is impulse signal, discrete time impulse, continuous time impulse, and whatever transform you want to evaluate, it is always equal to the 1 for the impulse signal. So let's have a look into this, starting with one of the very basic, then going to the more important case. The xz, as I told you, is given by the formula summation of the xn z raised to the power minus n from n equal to minus infinity to infinity in general. Now this can be written as summation minus infinity to the infinity delta n z raised to the power minus n. Thank you Satish. Right. So now we all know that discrete time unit impulse sample is given to you. A discrete time unit impulse sample, and definitely that discrete time unit impulse sample will exist only at n equal to 0. Delta n exists only at the n equal to 0. Thank you Ashok. Delta n exists only at the n equal to 0. So why to take the limits? You can only take n equal to 0. No need for the entire limit. So it becomes the delta 0. And then eventually you take z power minus 0 also. Delta 0 is known as the 1, z power 0 is known as the 1, and the final answer hence is equal to the 1. The final answer hence will be equal to 1. Correct. So you have the first Z transform pair, delta n is having the Z transform equal to 1. We have delta n having the Z transform equal to 1. Now we commonly represent the Z transform. As a double-sided arrow. Okay, let me also have a mark of this. We commonly represent a Z transform, right, either by this kind of double-sided arrow, or we write down xn and xz, Z transform pair, by this sort of double-sided arrow, which simply means correct Saumitya, correct. Good evening Vishnu. Right guys, so just inform all your friends, share the session so that all the students preparing for GATE are updated about this sessions, right? Okay, attendance has to rise. This is little less. Now guys, xn is having the Z transform, so xz is having the inverse Z transform, that is xn, right? If xn is having the Z transform, that is xz, vice versa, xz has the inverse Z transform, that is known as the xn. That is why we represent this as a double-sided arrow. And we have the first important case, xn having the Z transform 1. So with this, you can also note down the Z transform of shifted unit impulse, delta n minus k. Now, shifted unit impulse Z transform, because this is also very commonly used in some of the questions. See guys, A to Z type of question of Z transform will be covered in this week, right? Z transform and DTFT, A to Z, any type, whether it is a simple or even the toughest question of Z transform will be covered. That is what I can ensure you from my side, right? You have to stay updated throughout the week if you want to have total mastery in the Z transform and DTFT. Total mastery in the Z transform and DTFT. Stay updated throughout the week. Yes, all the variety of questions you will be able to attempt henceforth after this lecture. Now, delta n minus k. Now, one way of deriving the Z transform is using the time shift property, but properties I am going to cover tomorrow. Don't worry regarding to it. Properties I am going to cover tomorrow. So, what we can do right now is, so delta n minus k is a shifted impulse, na? So delta n minus k equal to 1 at n equal to k. When n minus k equal to 0, that is n equal to k, it's a shifted impulse. So when I want to write down its Z transform, it becomes the summation of xn z raised to the power minus n. But once again, no need for the summation, because impulse is only defined at one point, that is n equal to k. That is n equal to k. To directly take the n equal to k, and at the n equal to k, delta n minus k is equal to the 1 and multiplied by z power minus k. So the answer is eventually z power minus k, which can also be studied as the time shift property, which we are going to discuss tomorrow. Properties kal discuss karenge. All properties will discuss tomorrow. Now coming to one of the very important case. You will feel throughout the sessions that we are going to have, you will feel that this is one of the very important signal. Okay, what is the Z transform of xn equal to a power n un? a power n un, a right-sided sequence. Very, very, very important here is a right-sided sequence discussion. Okay. Good evening, Chandrasekhar. Z transform of a power n un, right-sided sequence. Right. Right-sided sequence. Okay. Chalo. So let's discuss the story for this right-sided sequence. Okay. So what is this a power n un eventually? This a power n un, if I just give you an idea, it's an exponential signal, and especially if the modulus of a less than 1, it's a decreasing exponential. Eventually turning out to be 0, right? So this is what is the waveform. This is what is the waveform for a power n, that is the right-sided sequence, a power n un, where I have taken modulus of a less than 1. I have sketched it for modulus of a less than 1. Thanks, Rahul. Okay, for modulus of a less than 1, and it is just like a exponentially decaying waveform. Exponentially decaying waveform it is, right? Okay. Now, what is the Z transform eventually? What is of our importance is calculating the Z transform of this signal. So let's come to the calculation. X of Z is given by summation from minus infinity to the infinity xn. Put down the value of xn, a power n un, multiplied by Z raised to the power minus n. Multiplied by the Z raised to the power minus n. Right. So this now becomes, now guys, unit step is involved. Because of the involvement of unit step, see, either graph also very clearly tells you, from the graph also itself, you are able to say that the signal is right-sided starting from origin. So the limit has to start from 0, because there is nothing at -1, there is nothing at -2, right? The signal has to start from 0, or else if you forget the graph, if you don't sketch the graph, no need to sketch the graph also, right? If un is involved, to un equal to 1 only for n greater than equal to 0. un equal to 1 for n greater than equal to 0, or for n less than 0 it is 0, and if the un is 0, the whole summation is 0. The whole summation is 0. Okay sir, so summation ko 0 nahi karenge, right? So let's take n greater than 0. So the now limit should become summation 0 to infinity a raised to the power n z raised to the power minus n, that is summation n equal to 0 to infinity. Both the powers are n, so let us combine a, and this is z power minus n. So z power minus 1 whole power n, and now open the summation, guys. Simply open the summation. So starting from 0, it is 1, then az inverse whole square, n का value बढ़ाते जाएंगे, az inverse whole cube, az inverse raised to the power 4, and etc, etc, etc till infinity, till the infinity, right? Hi Nani. Okay, now what is this? This is basically a GP coming up in front of you. This is just what is a geometric progression, having the first term of 1 and the common ratio az inverse, having the first term of 1 and the common ratio of az inverse. So what is the formula for GP with infinite number of terms? GP with infinite number of terms has to be given as the answer a upon 1 minus r. A means the first term, which is 1. So the answer, if I want to write down here, so the answer xz should be equal to first term divided by 1 minus common ratio. A is divided by 1 minus az inverse. Common ratio is az inverse, but the GP with infinite number of terms will only and only be convergent. A GP with infinite number of terms can only and only be convergent if modulus of r less than 1, magnitude of common ratio less than 1. Now this arises an important conclusion. Modulus of r here is az inverse. should be less than 1. So let's have a closer look into this particular case. Modulus of AZ inverse, that is modulus of A by Z, should be less than 1, or vice versa. I can say mod A less than mod Z, or mod Z greater than mod A. Mod Z greater than mod A. So what is the Z transform, guys? What is the Z transform? If I want to write down the Z transform of A raised to the power n un, it has a Z transform 1 upon 1 minus AZ inverse, or you can also write down in the positive power of Z. This can also be written as multiply throughout by Z. This can be written as Z divided by Z minus A. This can also be written as Z divided by Z minus A, but with a very important condition. Without that, the Z transform cannot exist, because if modulus of R is greater than or even equal to 1, the GP does not converge. It becomes infinity. Z transform will be infinity, that is undefined. So very important condition, students, is modulus of Z should be greater than modulus of A. Modulus of Z should be greater than the modulus of A. Modulus of Z is greater than the modulus of A. Modulus of Z is greater than the modulus of A. A power n un has a Z transform Z upon Z minus A, 1 upon 1 minus AZ inverse is mod Z greater than mod A. Now what is this condition representing in front of you? That there are only certain values of Z which satisfy mod Z greater than mod A, for which the Z transform is defined. Now this condition, mod Z greater than mod A, can we sketch this condition? Mod Z greater than mod A, can we sketch this condition? So guys, forget the inequality. If I just take mod Z equal to mod A, isko to sketch kar sakte hain na. Mod Z equal to mod A, we all know, is a circle. Once again, I have shown you in the beginning also. Once again, let me review. It is a circle with the center at 0, 0, and the radius equal to modulus of A. Modulus of A I am taking because A may be negative also, A may be complex also. Modulus of Z Z equal to modulus of A. So let's have an equation of the circle first of all. Let us first of all have the equation of the circle. Right in front of you. Okay, so here let me bring you the circle right in front of you. Have a look into this. This is the circle having the radius modulus of Z equal to modulus of A, right? And Z upon Z minus A, guys. What is the pole of this function? There is a Z transform. What is the pole of this function? I hope you all remember, you all know what is the pole. Pole is the value of Z. Pole is the value of Z for which the function is undefined. So if you take Z is equal to A, if you would like to take Z equal to A, so it becomes A upon 0, which is undefined. So pole is Z equal to A, right? Let me also mark down the pole here. Radius is also equal to the magnitude of A, right? This is the circle, right? But I want to sketch modulus of Z greater than. So any point on this circle, satisfies mod Z equal to mod A. So if you want modulus of Z greater than modulus of A, so you have to go beyond the circle. You have to go exterior of the circle. Sir, you have to go to the exterior of the circle. Let me quickly sketch it as a freehand curve. Just a second. Any confusions? Please do let me know. Yes. So modulus of Z greater matlab kitna greater? It can be any greater, na? It can go up to infinity also. Only condition is modulus of Z should be greater than the modulus of A. Modulus of Z should be greater than the modulus of A. So I take the region which is the exterior of this circle. I take the region which is simply known as the exterior of the circle, and this particular region, guys, is known as the ROC. I told you there are only a specific values of Z which satisfy mod z greater than mod a, for which Z transform is defined. When I plot this, when I sketch it, it comes out to be a region exterior of a circle. So there is a certain region in the Z plane for which the Z transform of the given function is defined. Otherwise, the Z transform is not defined, and we technically call it as ROC, that is known as the region of convergence, which is the range of values of Z. Yeah, region in the Z plane, ऐसा भी बोल सकते हैं. Region in the Z plane, the complex plane for which Z transform is defined. For which Z transform defined converges is known as the region of convergence. It is simply known as the region of convergence. I will show you different variety of questions that can be expected from ROC and Z transform, but yeah, slowly, within all the classes. Okay, in all the classes. Okay, but I ensured you one thing. I again ensure you that if you just be regular throughout the week, the Z transform and DTFT, two important concepts with all variety of question, easy, moderate, and even the most challenging question will be able to discuss in the class, right? We'll be able to discuss with the class. That is what is the physical significance of ROC. It is that region where Z transform can be defined. So only thing is, Ashok, that with respect to this condition, we are just trying to plot it up. What point I should take in the Z plane, maybe this point I take, Z transform is defined. If I take this point, Z transform is not defined. Right. So we know that Z transform is an important tool related with the eigensignal, related with determining the outputs of LTI system. So we must be very aware where does the Z transform is defined. We can't blindly use the Z transform if it is not defined. Right. If it is not defined. So let me take up a simple example here. Suppose if I want to discuss with you. Right. What should be the Z transform of? Sir, what should be the Z transform of half power n un? Now everyone will be able to write down this answer easily, na? What is the Z transform for half power n un? Sir, it is given by xz, which is 1 upon 1 minus az inverse, or it is equal to z upon z minus a. You can remember both the formula. 1 upon 1 minus az inverse or z upon z minus a. But never write down the Z transform without the ROC, because if you write down this expression, I can say that I can put any value of z. But no. This is only defined for the value of z which satisfies mod z greater than half, mod z greater than modulus of a, mod z greater than modulus of a. Sir, even the a can be negative, I told you, na? Even the a can be negative. So suppose if I want to discuss a question with you, if I want to give you xn, which is equal to minus of 3 power n un, minus of 3 power n un, minus of the 3 power n un. What is the Z transform? No problem, sir. Let us write down very quickly once again. Ultimately, it's a power n un. So 1 upon 1 minus 3 will become plus 3. Okay? 1 upon 1 plus 3 Z inverse, or that is equal to Z upon Z minus a. Z upon Z minus a, minus 3 again becoming plus 3 with the condition mod Z greater than modulus of a. So what is the modulus of a here? Modulus of a will be 3 only, na? Modulus of minus 3 is 3. So mod Z greater than minus 3. ऐसे मत लिखना कभी. Don't write down. Some students commit this basic mistake I have seen. Mod Z greater than minus 3, na? Mod Z greater than modulus of a. That is mod Z greater than the 3. Be very specific here. Right? Be very specific here. Okay? Even the question can be of this form. Suppose if I want to discuss a question, students, what is the Z transform of 1 plus j raised to the power n xn? 1 plus j raised to the power n xn. Can we find the Z transform of this? So the value of a is 1 plus j. No problem. Na? I told you a may be positive, negative, complex. Right. So what will be the modulus of a? That is what you should always take care. Modulus of a will be square root of 1 square plus 1 square, square root of x square plus y square. That is square root of 2. That is the square root of 2. Now you can write down its Z transform easily. The Z transform is given by 1 upon 1 minus az inverse, or it is given by z upon z minus a. Z upon Z minus 1 plus j with the ROC. with the ROC mod Z greater than root 2. Eventually ROC will be in the form of a circle, exterior of circle or maybe interior of circle. Exterior or interior of circle. When it will be interior? When it will be the interior, wo bhi batata hu, right? So even A can be complex, guys. Don't be worried. Don't think it is some new question. It is the very same concept only, right? With the ROC mod Z, now with the ROC if you write, mod Z greater than 1 plus J, it looks like nonsense. Because especially for complex number, you don't have inequalities. Complex number mein inequality kabhi nahi hota, right? So you cannot write mod Z greater than 1 plus J. Okay, you have to take mod Z greater than mod A, and the reason I explained you already. Reason is the GP reason, the convergence of GP. Modulus of R less than 1 gave me this condition. So similarly guys, if I want to discuss a left-sided sequence, okay, now similarly if I want to discuss a left-sided sequence, guys, here there will be the very similar calculation, right? Okay, so again solving by GP, because very same calculations are going to come. So let's not waste time in repeated derivation. Okay, so again solving by the GP method, what is the answer you are going to get? Because it is the very same, so let us not waste time in calculation. We will calculate if it is something new. A power n u minus n minus 1 will have the Z transform minus 1 upon 1 minus a Z inverse, only a negative sign difference will come, or minus Z upon Z minus a, only a negative side will come, but with the condition, when you solve this GP, there will be a condition coming up, mod Z less than mod A. There will be a condition coming up, mod Z is less than the mod A. I am assuming that you can solve this by the GP, okay? That is why I am just skipping this calculation, because it's a very basic calculation. So I am assuming that you can solve this by the GP. The modulus of Z is less than the modulus A. It's going to be what case now? Let's learn with example, right? Modulus of Z less than modulus of A. What is the sketch corresponding to this? What should be the sketch corresponding to this? Right? What should be the sketch corresponding to this? Root 2 is greater than 1, Shekhar. No issues. See, root 2 can be greater than 1, Shekhar. Issue nahi hai. Dekho, let me go back. Let me first complete this and come to your point. Okay, chalo, let's not interrupt. So guys, once again the idea will be same. First, mod Z equal to mod A. First, less than or greater than, forget. First, let us sketch the mod Z equal to mod A. First, let me sketch the mod Z equal to the mod A. First, let me sketch the equality. Mod Z equal to mod A. Everybody knows that it is a circle. Everybody knows that it is a circle with the radius equal to mod A, and Z equal to A is once again the pole also. So let me highlight the pole also. Z equal to A is the pole, right? U minus n minus, see, U minus n is also left-sided, Saumitya, U minus n. So when you want to talk about U minus n, it will start from origin. Okay, but already the right-sided sequence, see what we want to do here is, look into this. Saumitya, we have already defined it in discrete time, the U and K start from origin, n equal to 0. If you take the U minus n, that will also start from origin. So just to totally complement it, we commonly define the left-sided signal as the one which is starting from minus 1. Just to totally complement it. Iska total invert karne ke liye, we try to define a signal which is starting from the minus 1 going till minus infinity, excluding all those values which are in the UN. And that is why we defined U minus n minus 1. Why? Dekho na, if it is minus n minus 1, what is the story of U minus n minus 1? U minus n minus 1 will be equal to 1 if minus n minus 1 greater than equal to 0, and this means n less than equal to minus 1. So this unit step will be equal to 1 if n is less than equal to minus 1, just the totally complement of the UN case. Okay, so yeah, I was trying to sketch this. So modulus of Z less than modulus of A. Okay, so what is the ROC here? Let me just plot this like this. This portion is basically what is the ROC here. This portion here is basically the ROC. Are you getting it? This portion is basically the ROC for the left-sided signal. So what do we understand? What do we understand? For left-sided ROC is interior, for right-sided ROC is exterior. Sir, if the signal is two-sided, वो भी बात करेंगे. If the signal is two-sided, that also we are going to talk. Don't worry. उसकी बात भी करते हैं. But yeah, one important point that Shekhar was raising. Let's talk about that, guys. Definitely root 2 is greater than 1. There is no condition in that. Yes, root 2 is greater than 1. कोई problem नहीं आएगा. But have a look into this. Have a look into this case. Let me pick up any one example here. ये यहाँ पे blank क्यों छूट गया है? Okay, let's take this example. Where is that example? Come to this. Xn equal to half power n un, guys. Listen to me. Xn is half power n un. Whose Z transform we already calculated. Mod Z greater than 1 by 2. Mod Z greater than 1 by 2. So can the mod Z be equal to 1? ध्यान देना. Mod Z greater than 1 by 2. Pole is 1 by 2 and mod Z should be greater than 1 by 2. Right? Unit circle has the radius 1. Unit circle has the radius 1. So modulus of Z is greater than half. So modulus of Z can be equal to 1. Now any value greater than half is accepted. Right? Any value greater than half is accepted. So mod Z equal to 1 is acceptable. And whenever you evaluate the Z transform on the unit circle, that is known as the DTFT. DTFT is the Z transform on the unit circle, but you have to see whether the unit circle is there in the Z transform or not. So mod Z equal to 1 defined hai. So for this signal DTFT is also defined. Sir, what is the answer for DTFT? Wait, we will cover DTFT in another class. But yeah, I am giving you the primary hints. I have given you the initial hints that what is the basic connection between the DTFT and the Z transform, right? But now if I want to discuss the next case, let me draw here roughly only. So now you have radius 3, modulus of A is 3. Okay, I'm just doing it without any colors. Let me draw a black diagram here. So where is your unit circle? Unit circle has the radius unity. Right? So what about mod Z equal to 1 here? Modulus of Z should be greater than 3. It cannot be equal to 1. Modulus of Z equal to 1 is not allowed, right? And if modulus of Z equal to 1 is not allowed, so can you define the DTFT for this signal? Come on everybody, we can say that for this particular signal, DTFT doesn't exist. I'm again and again telling, we will talk more about DTFTs in the coming class. Right, in the coming class, separate DTFT class and its properties. We'll take another classes for DTFT. Right. Okay, we'll take another classes for DTFT. Right. Okay. So just remember that. Just simply remember that DTFT does not exist. So what I can say now eventually, what is the condition for existence of DTFT? Right? What is the conditions for existence of DTFT? Looking into the Z transform, I can say that whenever the unit circle is inside the ROC, DTFT will be defined. Whenever the unit circle is not inside the ROC 3 के बाहर जा रहा है, unit circle is at 1, but that means it is not a part of units, it is not a part of ROC. DTFT does not define. Okay, so let me put down one important conclusion here. Forget this, let's come here. Yes, since I have defined this ROC and DTFT, if the ROC includes the unit circle, then the DTFT also converges. So yes, I'm telling you, again we will discuss the DTFT in separate classes, but let us set a foundation for it. Let us set a simple foundation for it, right? So guys, these are the two very important results. These are the two, already we have discussed this. These are the two important results. A power n un, z upon z minus a, or it is also equal to 1 upon 1 minus a z inverse. 1 upon 1 minus a z inverse, mod z greater than mod a. Oh sorry, a small typo error is here. Similarly, now what formula I defined? What formula I defined? I defined the formula for a power n u minus n minus 1. So if I want to place a minus sign, then what happens? If I want to place a minus sign here, right? Okay, so this minus sign from here will be getting cancelled. That's it. So minus a power n, minus of the a power n, u minus n minus 1 will have the same Z transform, Z upon Z minus a, yeah, 1 upon 1 minus a Z inverse for modulus of Z less than modulus of a. Modulus of Z less than modulus of a. So if you are liking, if you are enjoying the concepts and if you are actually learning the concepts, do not forget to hit the like button. Do not forget to hit the like button. Now let's go to some unit step ka bhi dekh lete hain. Unit step is very simple. Now in the a power n, simply take a equal to 1. In the a power n, simply take the a equal to 1. And if you take the a equal to 1, this becomes Z upon Z minus 1. This will simply become the Z upon Z minus 1. This will simply become the Z upon Z minus 1. Z upon Z minus 1. Yes? So Z upon Z minus 1 or also 1 upon 1 minus AZ inverse, A ka value 1 rakha. Right? Modulus of Z greater than 1. Modulus of Z greater than 1. So this is what is the Z transform of the unit step signal, unit step sequence. Unit step signal or the unit step sequence. Now let us come to some of the important properties. See, the total properties of Z transform and ROC we will see in the tomorrow's class also. Tomorrow's class is titled as Z transform properties and the ROC properties. But since we have launched with the discussion of ROC, we need to discuss some important points about the ROC. We need to discuss at any cost some important points about the ROC. Let's have a look into this, right? So first of all, what is the observation? The ROC consists of circular regions in the Z plane, and it may be exterior of a circle or interior, but it is a circular type of region that is coming. It is always looking like a circular type of region. This is interior of a circle. The first case that we saw was the exterior of a circle. So eventually it is a circular type of portion. It is a circular type of portion. Maybe exterior, maybe interior, or maybe one more case I am going to talk about. Right? But ROC is always like circular region. And that too centered at origin. That too centered at origin. कभी ऐसा ROC नहीं मिलेगा आपको, right? I 100% sure you will never get this ROC, neither in the exterior form nor in the interior form. That is 100% guaranteed. So it is always in the form of circular region, that too centered at the origin. That too centered where? Centered at the origin. Number one important point about ROC. Right, as I have already shown you, ROC cannot contain any poles. The simple logic, once again let me repeat. Because pole is a value where Z transform is undefined. At the pole, the Z transform is undefined. ROC is a region where Z transform is defined. So they are complement of each other. They cannot be together. So ROC can never contain any poles. ROC can never contain any poles. Third pe baat mein aayenge. Let us go to the fourth one. If xz is rational, we'll more talk about rational functions separately, right? If xn is right-sided, then the ROC is the region in Z plane outside the outermost pole. See, till now we have seen only one pole. Eventually we are going to see the functions which will have multiple poles, right? But the point is, whenever signal is right-sided, ROC will be exterior of a circle. You simply have to remember, if xn is right-sided, right, the ROC will be in the form of exterior of a circle. ROC will be exterior. For left-sided signal, interior. That is what is fixed. But exterior of what? Right, exterior of largest pole, or I can say it as outermost pole. For example, let me take one example here. For example, if I only give you a data, right, if I only give you a data, xn is a right-sided signal, right, and I give you xz, and let xz as an example, suppose be it equal to z is divided by z minus 1, z minus 2. Suppose that is a Z transform given. We will see for some signals such type of Z transforms are coming up. Such type of Z transform are coming up. So suppose it is equal to z upon z minus 1, z minus 2. Z upon z minus 1, z minus 2. So what should be the ROC? What should be the ROC? Blindly you can say that, okay, blindly you can say that because it is right-sided, Because it is right sided, ROC will be exterior of circle, and exterior of what guys? Exterior of the outermost pole. So सबसे बड़ा, सबसे outer कौन सा हुआ? Outermost is the 2. The largest one or the outermost pole has the 2. So what should be the ROC for this one? Quick sketch. What should be the ROC for this one? The ROC for this one will be equal to mod Z. ROC for this one will be simply equal to mod Z is greater than 2. This is the pole 2. There is also one more pole at 1. Right? Okay. See, the simple idea is, can the ROC be mod Z greater than 1? ऐसा सोच के देख लो. Can the ROC be mod Z greater than 1? Right? Can the ROC be mod Z greater than 1? Right? If the ROC is mod Z greater than 1, then it will include a pole, na? Then it will include a pole, and ROC cannot include pole. That is why ROC has to be going beyond the last pole, going beyond the outermost pole, beyond the outermost pole. And this is what is going to be the ROC. Let me draw. This is the ROC for the signal. We will take up multiple more questions on Z transform and ROC in tomorrow and Wednesday class. Don't worry regarding to it. Okay guys, right? This is what is the very important property. Similarly guys, if a signal is left-sided, what we observed? Already we have observed, I'm just putting it as a property. If a signal is left-sided, then what about the ROC? Then the ROC is interior of circle. But interior of what? ROC is interior of circle and lying inside the innermost pole. Interior of innermost pole. सबसे छोटा pole. Lying interior of innermost, smallest pole. Right? So for left-sided signal, ROC is interior of a circle, lying interior of the innermost pole. That means if I just say that the same signal is left-sided, and if I give the same type of Z transform expression, if I give a Z transform which has the poles at 1 and 2, then your ROC will be mod Z interior less than, mod Z less than what? Less than the smallest pole. So this should be the interior. If I make it as left, okay, then forget the first ROC. This is going to be the ROC. I'm not redrawing it, I'm just showing in this figure. Are you okay with this? Okay, chalo. This is right-sided, left-sided. Now third case I told you, the signal is neither totally right-sided, nor it is going to plus infinity, neither it is going to the minus infinity. Now wo plus infinity jayega, now wo minus infinity jayega. Right? Neither it is going to the plus infinity, neither it is going to the minus infinity. Right? If it is a finite duration signal, then the ROC is entire Z plane. Then the ROC is entire Z plane except possibly 0 or infinity points. Why sir? Why possibly? Why not confirm? Let's talk about that. And do not forget to like the session if you are just enjoying it. Right? So finite duration. Let's take an example and understand this, guys. Let us take an example, or rather a question, and let's understand. So if I give you very simple case, xn equal to delta n. Arey sir, for delta n I have already derived, na? For the delta n we have already derived the Z transform, and that was equal to how much? That was equal to 1. It is a constant 1 irrespective of the value of Z. It is equal to constant 1. xz equal to 1 for all values of Z. xz is equal to 1 for all the values of Z. For all values of Z. So what is the ROC in that case? What is the ROC? See, if you remember what was the calculation, it was summation of delta n Z power minus n. Just recall, right? Delta n exists only at n equal to 0. In general, the limit is minus infinity to infinity, but this is only at n equal to 0. So Z power 0 is finite. Delta 0 is also finite. Finite into finite is always finite. Z transform is always convergent. Always convergent. So what is the ROC? What is the ROC, guys? The ROC here is known as entire Z plane. The ROC here is known as the entire Z plane. The ROC here is known as the entire Z plane. All okay guys, the ROC is the entire Z plane. Okay, but now let me take another question. Xn is equal to, suppose 1, 0, 2, 3. Let's take this with the origin at 1 only. Xn is 1, 0, 2, 3. 1, 0, 2, 3. Now, if I want to represent this as, if I want to calculate its Z transform, what will be the Z transform? Summation xn z power minus n, in general from minus infinity to the plus infinity. In general from minus infinity to plus infinity. तो अब देखो, सबसे पहले the summation will start from n equal to 0 actually, because the signal is starting from n equal to 0. ठीक है, signal value 1 z power minus 0 plus the signal value 0 z power minus 1. ये z की सीरीज चलेगी. Signal value 2 z power minus 2. Signal value 3 z power minus 3. So what is the Z transform eventually? The Z transform eventually is 1 plus 2z power minus 2 plus 3z power minus 3. 3z power minus 3, or it is equal to 1 plus 2 by z square plus 3 by z cube plus 3 by z cube. Now, does this function have a pole? Does this function has a pole? Does it have a pole, guys? So clearly 1 upon z is coming in the denominator and the pole is z equal to 0. 1 upon z is coming in the denominator and the pole is z equal to 0. And the pole is z equal to 0. And the pole is known as the z equal to 0. And if there is a pole, it cannot be in the ROC, right? So it is a finite duration signal. The total length is 4. The total duration of the signal is 4. It is finite duration, but it is finite duration, but z equal to 0 cannot be in the ROC, right? So what is the ROC? It is entire Z plane, finite duration, entire Z plane, right? But except z equal to 0. Pole cannot be inside the ROC, so except z equal to 0. Got it? Except the z equal to 0. That is what I can say. Okay? Except the z equal to 0. All cool. Right? This is what is the ROC, finite duration signal. Maybe sometimes infinity to be included. Sir, why? एक और example देखते हैं. Let me just quickly tell you one more example. Suppose xn has been given to you as 4, minus 1 and 2 and 5, suppose. With this is the origin, this is the n equal to 0, right? So what should be the Z transform now? What should be the Z transform? The signal is starting with n equal to minus 1. 4 z raised to the power minus of minus 1. xn z power minus n, that is the formula. I am directly applying the formula. Plus signal value minus 1 z power minus 0. 2 z power minus 1 z power minus n, okay? xn z power minus n pattern I have to multiply. 5 z की power minus 2. n का value एक एक करके increase कर रहे हैं, right? So what is the eventually answer? X of z is equal to z power minus of minus 1 is plus z, 4z, then minus 1 plus 2z inverse, that is 2 by z, plus 5 by z square. So what are the poles now? Definitely z equal to 0 is again a pole, because it is in the denominator. The 1 upon 0 makes infinity. 1 upon 0 tends to infinity. So z equal to 0 the pole hai. But what about infinity? Z equal to 0 is a pole. What about infinity? 4 into, see, 1 upon infinity will be 0. This is finite. 1 upon infinity is 0. This is known as the finite. This is known as the finite. But 4 into infinite. 4 into infinite will be infinite. So even if you put z equal to infinity, the function will be infinity, and hence the Z transform is infinity, and hence it is a pole. So there are poles at 0 and infinity. So what should be the ROC, sir? What should be the ROC once again? Entire Z plane. Entire Z plane except the poles, because it is finite duration. So entire Z plane, but except z equal to 0 and infinity. This time you have to accept both. You know, you have to exclude both. Yeah, we'll plan maths also very soon, Arun, this month. Don't worry. Okay, so that is what, if the signal is of finite duration, ROC is entire Z plane except possibly, that too not sure. Sometimes you have to exclude, sometimes not to exclude. Depending, if it is a pole, exclude, otherwise include. Except possibly 0 or infinity. Okay, chalo. Then we have seen the right-sided signal already, very important with this example. Left-sided signal again, very important, we have seen. Okay. But if the signal is neither finite duration nor going to the right totally nor going to the left totally, if it is two-sided, if the signal is two-sided, next important case, if the signal is two-sided, well, let's take an example of two-sided before learning more. Suppose xn equal to a power mod n, and guys, if you are really liking, enjoying, do not forget to like the session, so that it's just a message for us that what type of content you're looking, whether you're liking the content. So yes, we try to bring that content, because YouTube, we are especially coming free live for you in the free courses. So we really need your response, ki what type of content you like more, what type of content should be brought to you more, right? To express your motivation and express your interest in these sessions, and so that I can also understand, yes, how much worthful it is. Just watching does not make sense. If you are really concentrating, then you will definitely put some response, maybe like or dislike, right? Chalo. Yes. I'll give you the PDF also. Okay. But as always, the PDF, so Ashok has raised the point. Let me tell you, PDF is again going to be password protected, and the password for the PDF is going to be very simple. Today's PDF password will be very simple, and that is ZT. That is simply going to be ZT. ZT. Small z, capital T. Small z, capital T. Right? Very simple password for today's PDF, which will be there in my Telegram group. Right? So book-wise, it is Oppenheim, the best book, Gajendra. Okay. Find the Z transform for a power modulus of n. So now try to understand this signal. Xn is equal to a power modulus of n. A power modulus of n, and a power modulus of n, right? Modulus of n is equal, simple mathematics, guys. Modulus of n equal to n whenever n is positive. If it is already positive, so why to consider the mod? It is already positive. But if it is negative, for n less than 0, modulus of n is known as minus n. Modulus of n is known as the minus n, the very basic modulus definition. Or I can say that xn is a power n, for n greater than 0 multiply un, plus it is equal to a power minus n less than 0, as I have already shown you in the beginning of the class. In the discrete time, right sided means un, and if you want to represent left sided, totally complement of right sided, a signal left sided which is starting from -1 to -infinity, I have shown you that signal is u minus n minus 1. Isliye the next part, n less than -1. N less than -1 means n less than equal to -1, starts from -1. So such a signal is u minus n minus 1. Such a signal is u minus n minus 1. So xn is equal to a power n un plus a power minus n, that is a power minus n, that is 1 by a power n u minus n minus 1. 1 by a power n u minus n minus 1. Correct. We are interested in what? We are interested in the ROC right now. हम ROC को figure out कर रहे हैं, right? So what should be the ROC? Now see guys, one of the part is right sided, one of the part is left sided. So this signal is a combination of right sided and left sided. This is a combination where one part is going to the right also, one part is going to the left also. So it is a two-sided signal. It is a two-sided signal. What should be the ROC for this? This is known as the two-sided signal. So what should be the ROC for this? It is known as a two-sided signal. So what should be the ROC for this? So dekh lete hain. What is the ROC for this? What should be the ROC for this? Yes, Aditya, correct. We have to take the common portion. So what is the ROC for the first one? Right. What is the ROC for the first one? Right. A power n u and ROC. We all very well know that mod z greater than mod a. We all very well know that mod z greater than mod a. Left sided, mod z less than mod a actually, na? Mod z less than mod a, but here it is not a power n. 1 by a power n, तो यहां पे भी आएगा 1 by a, mod z less than mod 1 by a. Now we have to, hi, good evening ABD, we have to take care of both the parts. We have to take care of both the signal. If any one of the ROC fails, if any one of the Z transform fail, the total answer will also fail, right? So for the Z transform of the entire signal to exist, this should also be true. This should also be true. Matlab, you have to take an intersection, right? You have to take what? You have to take intersection. We will talk more about the intersection type of cases in the next class also, right? But you have to take intersection. Thank you ABD, thank you for your love. So mod z greater than mod a and mod z less than 1 by mod a. Okay. Now here there is a condition. Here there is a condition. For example, if I want to take a is equal to 1 by 3, ध्यान देना, a equal to 1 by 3. So modulus of z greater than 1 by 3 and modulus of z less than 1 by a, मतलब less than 3. Right. So mod z should be greater than 1 by 3 and greater than 1 by 3 and less than 3. Yes. So we can write down 1 by 3 less than mod z less than 3. That is definitely possible. But if I give you an example, suppose a का value 2 ले लिया, suppose a का value 2 ले लिया, then what should be the answer? So try to think now. Mod z greater than mod a, that is mod z greater than 2 and mod z less than 1 by a, less than 1 by 2, mod z less than 1 by 2. Mod z less than 1 by 2. So now mod z greater than 2 and mod z less than 1 by 2. What should be the answer? Mod z should be greater than 2, also should be less than 1 by 2. What is the answer? Mod z greater than 2, also less than 1 by 2. What is the answer now? But it is not possible. Now, if it is greater than 2, it cannot be less than half. If it is less than half, it cannot be greater than 2. So there is no common ROC. There is no ROC in the second case. So the conclusion is, I will put it like this: for the signal a power modulus of n, for the signal a power modulus of n, which is two-sided, what is the ROC? What is the ROC? Yes, mod z should be greater than a but less than 1 by a. That means it should be between a to 1 by a. It should be between a to 1 by a. It should be between a to 1 by a. We all agree with that. But if modulus of a less than 1, if you have a condition like 1 by 3 or 1 by 2 or 1 by 4, if modulus of a less than 1, right? If modulus of a greater than 1, then there is no ROC. Then sir, what is the sketch for this ROC? Quickly isko bhi bana lete hain. Sir, what is the sketch for this ROC? What is the sketch for this ROC? Very next important condition. The next important condition. So what do you have? Mod z between mod a and 1 by a. So let's say this is the value of a. Let's say this is 1 by a. Right. So where is your ROC right now? Where is your ROC right now? It should be greater than a but less than 1 by a. That means your ROC, guys, will be looking something like this. Your ROC is going to look something like this. Your ROC is going to look something like this. Yes, guys, so you can see even the BYJU'S exam prep team is live and asking you to put your attendance by hitting the like button. Yes, right. That shows your expression, that shows your attendance, and that makes us decide the series, these classes for you. Right. Chalo. Right, this is what is the ROC, which is here in the form of a ring. Which is here in the form of a ring. Yes, guys, which is here in the form of ring. So that is what is the next point I was telling you. If the signal is two-sided, then the ROC will contain of a ring in the Z plane. Then the ROC is going to contain a ring in the Z plane. The ROC contains of ring in the Z plane. Ring in the Z plane. That is what is clear. It consists of a ring in the Z plane. Something like this. It's a ring in the Z plane. Okay. The ROC contains of the ring in the Z plane. Yes guys, so more concepts and more such cases coming up tomorrow, definitely. Yes, so a quick reminder that Thursday on the same channel at 11 p.m. Thursday at 11 p.m. on the same channel, right, I am bringing you a query that I'm facing recently by the students are how to maintain and make the notes, right? So not only how to make the notes, but I'll also talk about detailed notes, short notes, micro notes. What are more important? Okay, where to make details note, where to make short notes, where to make the micro notes, what is the difference between them and how to utilize them in this session on Thursday 11 p.m. on the same channel. So do not forget to subscribe our channel in case you are not subscribed, right? And once again guys, tomorrow on our app, a very, very important free mega GATE workshop by all your favorite Aminav Negi sir, right? IIT Delhi alumni and 10 plus years of experience in the GATE industry. He is going to speak about the do's and don'ts, what to do, what not to do, that also you must know during the GATE preparation, and that is live tomorrow, 12th July, tomorrow at 8 p.m. So register now on the BYJU'S exam prep app. So guys, that's it for the session. Do not forget to subscribe the channel in case you haven't subscribed, and I'll see you tomorrow guys, tomorrow, when we are meeting tomorrow at the same time, 9 p.m. 9 p.m. right now, you can lock it for signals and systems. 9 p.m. you can right now lock it for the signal and system. Let me see if the tomorrow's class is ready so that I can share with you and so that you are all ready for the class. So tomorrow is the properties. Tomorrow is the properties of the Z transform along with ROC. So some property of ROC we have considered. Okay. Okay. So that is the link of tomorrow's class guys. You can open the link and join the tomorrow's class at the 9 p.m. You can open the link and set the reminder so that you don't forget. And in case yes, you are subscribed, so anyways you get the notifications. Yes, Soumitra, definitely Z transform for maths and signals. No. And now there is no Z transform in the maths, Arun Kumar. Don't worry regarding to it. Okay. So that is the link of tomorrow's class. You can like, and if you want the Telegram link, let me share you that also, because today's PDF with the password protection, password I have told you earlier only, right, is going to be there in the Telegram. That is going to be there in the Telegram. So you can join the Telegram if you want to achieve the, if you want to get the PDF. If you want to get the PDFs, just join the Telegram, the link of which I am going to share now. Yes guys, this is the link of the Telegram. You can join the Telegram for the PDFs and updates of other classes. Okay, so bye bye. This is Rakesh Talreja signing off for today. Let's connect tomorrow at 9 p.m. Signal and system, actually daily at 9 p.m. Bye bye. Thank you. Stay safe and take care of yourself.